So I ended last time with the question, what if my redemption value is different than the face value? And I said I want to do an example where I had different options for the redemption. So let's consider a 15-year bond with a face value of 100 whatevers. And it's issuing coupons at 8%. And it's callable anytime between years 10 and 15. If you call it in year 10, you're going to get it at face value. So that's an at par call. But in 11 or 12 years, I'm going to let you call it and you'll earn more. And in year 13 through 15, I'll let you call it at even more. I want a price where I can guarantee a certain yield. I'm going to want to do this two ways. Let's start with trying to earn a yield of 12%. Okay. So let's think about the situation with a yield of 12%. Coupon rate is 8. So what's R? Half of it. And similarly, J will be 0.06. Wait a minute, that means that R is smaller than J. If R is smaller than J, am I buying at a discount or at a premium? And that means that my price should be lower than my redemption value. If I'm buying at a discount, I should pay less than what I'm going to get. Okay. If that's the case, when should I call the bond? As early as possible or as late as possible for each redemption value? As late as possible. So the minimum price happens as late as possible for each possible redemption value. Because this is redeemable at 3 different values, I need to figure out when I should do this. Okay, so up there it says I can do this in year 10 at par. My face value will be 100. So if I'm going to do it in year 10, I'm not going to do it at the beginning of year 10. I'm going to do it at the end of year 10. I'm going to do it the second couponing period. So I should call this bond after the second coupon has been paid in year 10. That means 20 coupons will have been paid. Similarly, at the 115 call, in year 11 or 12, what time should I call it at? Which would be what period? Right. And in years 13 through 15, I should wait until the very end, the last possible one, which would be after all 30 of them. And now I can go back and say, okay, how do I get the price? What's the price for my bond at each of these options? All right, hang on a second. That's the formula. All right. In this first case, I'm going to get, well, let me move it down here. That's not going to, one. Price is 100, 1.06 to negative 20th plus FR. Face value is 100. Coupon rate is 0.04. So that's 4A 20.06. Give me a number. Yes, ma'am.
I just have a question. Why do we change R to match the, like, this is semi-annual?
Yeah. By default, my couponing is semi-annual.
So why do we change R to match that and not J?
Oh, I did change J, didn't I? Because back at the beginning of this sentence, I said I wanted a yield of 12%, and that's why J is 6.
Okay.
I did cut it in half as well. Catch me if I don't, because if I screw up and I say I want to do this at 6, well, then I should pay a premium for the bond because the yield being 6% while the returns are 8.
Never mind, because I was thinking that it was 4, you just 4 minus the equals 4, but
Ah.
that's like no.
No, not in this case.
Yeah, that's what I was confused.
No, the 4 was just half the
Okay.
8, and coincidentally, it happens to be the difference in them. Okay, good. So at this time frame, I'd offer a price of 77.06 for this particular bond. Now, what if I held it longer? If I held it to year 12, then the call would be 115. And now we'd go to 24 coupons. By the way, in the exercises, I believe it's in exercise 18 in this section. there's a way to deal with that modified coupon rate G, which is CG equals FR. But that would just replace this FR with CG, so I didn't bother to do that. But we could write out a modified couponing rate because my face value and my redemption value are different. At this point, it doesn't do any difference in the equations, but keep that in the back of your head that some people will quote the modified coupon rate instead of the active coupon rate based on a par face value. But our redemption value is higher this time. What do we offer this time?
78.
And if we go to 15 years, my redemption is higher. My coupons aren't. Now, this one actually works out interesting to me. I find this to be a really interesting idea. This particular price, Adam,
78.56.
is lower than the shorter price. And we said, wait a minute, should the price, the longer I hold this, the more return I'm getting. There's a change in the effective couponing rate here. That modified coupon rate in this case, well, in this case, we're at par, so the coupon rate is the modified coupon rate. But in this case, the modified coupon rate, G is FR over C. When C goes up, my effective coupon rate goes down. Well, my modified coupon rate goes down. Now here it goes down to 3.5%, but here it goes down to under 3%. And that's the reason that effectively holding it longer doesn't cause that much of a price change. If I'm the buyer, what price do I want to offer to guarantee me a minimum yield of 12%?
Two.
The second one? But the second one is actually the highest price here, right? That the only way that's going to work is if I hold it to year 12. But I don't get to decide on the call date. The seller decides the call date. So if I want to guarantee myself that 12, I should offer the lowest price. I should bid 7706. And then no matter when the bond is called, I will make 12%. All of these assume 12% was my desired yield. I could do the same thing, and the textbook does, at a yield of 6%, which is lower, which means I'm going to pay a premium for all of these. But if I pay a premium, do I want to redeem early or late? So I would change the ends. And if I'm paying a premium, then I'd do this at 19. And I do this one at 21. And I do this one, well, I'd do that one at 29. No, 25.
What would the third one be at 19? Oh, it's the beginning.
The beginning of that year 10 rather than the end of year 10. I have to do it during year 10, right after the coupon is paid. So that's either at 19 or at 20. Now, it turns out in the last case, let me go back and write these numbers in. 0.035, 0296. If I say I want a yield of 6%, what's R? Say again? Yes. No, it's 0.4 because that's my coupon rate. Right. My G though changes, right? But my yield is now 0.03. Hey, wait a second. In the third case, my yield is bigger than my modified coupon rate. Should I redeem in the third case early or late? In all three of the examples that are up there, I didn't really talk about the modified coupon rate as meaning anything because my yield was higher and the modified coupon rate kept going down. But here my yield is low. My modified coupon rate goes down and suddenly my yield is higher than the modified coupon rate. And if my rate is bigger, I want to redeem late. So while I will agree with you, the first one should be at 19. The second one should be at 21. The third one should be at 30 because the rate is larger on the yield. Excuse me. So really, it's the comparison between R and J, as opposed to just the comparison between F and C. As a matter of fact, if we go back and look at the notes from Tuesday, I believe I said that we were actually looking at, hey, let's compare price and face value. Well, that's the same as comparing R and J. That's true for bonds at par. But when we're doing bonds that aren't at par, I need to compare J and G instead of J and R. Questions? The US federal government stopped issuing callable bonds a number of years ago. And so they created a new idea. And the new idea is called a retractable extendable bond. But it puts the calls not in the hands of the bond seller, but in the hands of the bond holder, the buyer. Always screw up spelling this one. Extendable is with an A. So that means I'm holding the bond. I'm the one who loaned you the money. I'm the one who gets to decide when you give it back to me. Within a certain framework, that's still negotiating. So I say, I want to retract this loan. I want to redeem the bond. Oops. Or they can extend it to a future date. Now, this actually brings up the idea that on any given callable date, which is again usually a coupon date, the bondholder can say, I'm redeeming the bond today, or they can say, I'm waiting till the next one. That puts the onus on the seller to have the ability to pay back the bond at any point in time. This changes the calling idea. However, calls are still a valid method of purchasing other equities. They don't work for bonds anymore, but calls are available for stock behavior. More on that later. There is another option called a warrant. And a warrant is a guarantee that you can purchase more of the bond at a guaranteed price. Now, the warrant specifies the guaranteed price. Frequently, it is the same as the price paid at the time of the issuance of the bond. It's not a requirement, but it is often the case. Questions?
Who sets the pricing?
Usually, that's still a negotiation. There's a bid and an ask. Sorry, an ask is higher and a bid is lower, and then they negotiate the spread down until they come to an agreement. Quite frequently, that's not a trivial negotiation. I know that the originating price, the one we see on the bond issuance report, is a result of that negotiation that probably takes 2 or 3 months beforehand. This is where my brain says Treasury behavior is opaque because we don't get to see that negotiation. We get to see what's called what the issue price states. But large bond brokerage houses do that sort of negotiation direct. I think for corporate bonds, that's a negotiation between the bank, the company, and the bank that the company uses to try and say, well, if Seton Hill wanted to issue a bond, I don't know that we would ever do such a thing. But if Seton Hill says, in order to raise money, we're going to promise to give you money back. We need it now. We'll promise to give you back. Somebody somewhere is going to give us the money to hold, right? That's the negotiation with the bond issuing group, Seton Hill. Can't imagine us doing that. But somebody somewhere has to have a negotiation to set that price. So Maria, let me ask you a question. Would you loan Seton Hill money? Do you trust Seton Hill? Okay. Why? What do you think will happen to the money you loan Seton Hill? So they'll default.
Very value when we say,
No, but I was hoping I was hoping you would. Just hoping,
You?
because, well, I already have.
That's
In a very legitimate sense, I mortgaged my entire future to this place, right? I said, I'm gonna work here. Um, so this is a matter of the negotiation behavior. If you don't think the issuer of the bond is trustworthy or stable or will have the ability to pay you back, that's a default risk on the bond issuer rather than on the bond buyer. So a bond is given a rating. Again, there are three major companies that do ratings: Standard and Poor, S&P, Fitch's, and Moody's Analytics rate companies on their credit worthiness. Do I think company X has the ability to pay back this money? And they issue a rating. And that rating corresponds to a credit risk. If there's a higher credit risk associated with loaning somebody money, the price should change, right? So I want to take this into account when finding present values. But this is where we start to ask probability games. And I start to say to myself, what gives? What's my possibility? Let's do an example. A bond has a default risk of 5% for the last 3 years of its term. So there's a 5% chance they're not going to have the money to pay you. So that means there are 6 coupons left. If they default, oh, I need 2 other pieces of information. Hang on. The face value of the bond is $100,000. And we're using a coupon rate at 14% semi-annually. So R is 0.07. If they default in any given period, then there's no coupon. And you can recover 50% of the face value. So I say to myself, I want to take this into account when thinking about the price of this bond. What's the chance? What's the thing I should offer as a present value if I want a yield of 12%? Now, I get to ask you about a prob and stats question. Somebody tell me expected value. What's the idea of expected value? Right, so I take the outcomes that are available to me, multiply each one by the chance of happening, and add that together. It's a weighted average. It's the same average we use in probability in Calc 2, where we do the integral of x times the probability density function. It's our center of mass equation. So it's the same idea in all three of those cases. Expected value here, we really only have two outcomes, default or no default, right? So let's see what could happen at any one of these coupon periods. So let's think about coupon period 1. If they do not default, what do I earn? According to this, if there's no default in that first period, how much money should I get? I should get a coupon, right? What's the value of the coupon on this bond? $7% of the face value. So I should get 7 grand. On the other hand, if they do default, then I should earn the $50,000. There'll be no coupon. What's that total up to? For both of it added together?
$9,150.
Is that jive with what you got, Joe?
Yeah.
Okay, good. Okay. Now, here's an interesting note. If I want to look at what's happening in the second period, what do I know happened in the first period? if I want to look at what happened in the second period, what do I know had to happen during the first period? They didn't default. So everything I do assumes they didn't default. I've already got to multiply by 0.95 because I know they didn't default the first time. So what's the chance they don't default the second time? It's also 0.95. So here, instead of just writing 0.95 times 7,000, I actually need 0.95 squared. They didn't default the first time, and they didn't default the second time. But over here, what's the chance? Well, it's 0.5, 0.05.
Sorry.
I keep doing it too, don't worry about it, it's not your fault. But that's the chance of default in the second period. But they had to get through the first period the first time. Oh. So notice how both of these calculations have an extra factor of 0.95 in them. Because I had to make it through the first period. It was only a 95% chance of me doing this. I would, because of the way I think about probabilities, I think of a tree diagram. I don't know how many of you have done or seen tree diagrams, but I think to myself, oh, there was a 0.95 chance of no default, and there was a 0.05 chance of default. That's how I got these two. But now to get to the second layer, I have to be here. So I have to do 0.95 and then another 0.95 or a 0.95 and then a 0.05 to work my way down the branches. But I don't have to do that on the right-hand side. Because on the right-hand side, we defaulted, we're out. So over here, there's nothing further in that direction. I don't know if this visual helps you or not, but I knew it helped me. So again, I want to work out what this number is. It should be smaller.
Says we're gonna do
8692.5. Great. Now, I get to the third period. The only way I get to the third period is if I didn't default in either of the first two. So I should have a 0.95 cubed for no default. And then I should have a 0.95 squared times 0.05 times 50,000. I have to make it successfully through the first two periods and then default in period number 3. Again, for those of you who have done any statistics, this looks like a binomial behavior. And again, I can pull a number here. I got 82, 57, 88. And I'm going to do this for all 6 calculations. But my pattern stays the same. This one on the left is 0.95 to the n times 7,000. This one on the right is 0.95 to the n minus 1 times 0.05 times 50,000. That works here as well. It changes just a little in the last period. In the last period, if they don't default, what do I get? I don't just get the coupon, I get the face value back. So that's the big number. But over here, I had to make it through the first 5 periods, then default, and then only earn $50,000. So again, I have numbers 78, 44, 98, 74.52, 73. This one's much bigger, 80,589.28. So this is the value of the bond at each different point in time, accounting for my default risk. So Maria, if there's a 5% chance Seton Hill's not going to give you your money, but you could recover half of it in the bankruptcy declaration, this is how we would value that. But I want to buy this bond right now. So what do I need to do with these numbers? I need the present value at an assumed yield of 12%. So my present value is the value in period 1 times 1.06 to the negative 1. 1/2 year at 12%, plus the value at period 2, 1.06 to the negative 2, and so on. 82, 57, 88, 1.06 to the negative 3. I forgot the other digits there. 1.06 to the negative 5. And then the 80,000, 1.06 to the negative 6. And this is how much I should value the bond today. What do you get? Well, again, calculation, calculation, calculation. $91,000. My yield was 12%. My couponing rate was 14. R bigger than J. The default risk is what made this go down. Questions? So let's suppose I actually pay this and no default happens. What do I actually yield if I make it all the way to no default? Well, this time I know the price. I know the face value. I'm trying to find the yield. So P equals F 1 plus R minus J, A, N, J. I want to figure this out. And I bought this 3 years before it ended, so I know that N is 6. 91,897.18 equals, the face value was 100,000. 1 plus R, couponing rate, 0.07 minus J. And then A, 1 minus 1 point, oh no, we don't know what that is, 1 plus J to the negative 6 over J. That's the thing I want to solve. I'm going to divide by the 100,000, so I get 0.91898718 equals the rest of this chunk, 1 plus 0.07 minus J, 1 minus 1 plus J to negative 6 over J. And now I need to solve this equation. And I'm 100% telling you I'm not going to solve this by hand. That's disgusting. So out comes my tech. I will graph the number 9189718, and then I will graph 1 plus parentheses 0.07 minus X times this 1 minus 1 plus X to the negative 6, negative 6 divided by X. Now this is going to give me a rate, a yield. My idea was that the yield would be 12%, right? But that's 2J, so I think J should be around 0.06. So if I'm going to look at this, this should be somewhere in that range. I'm going to set a really small window. I'm going to go from 0 to 0.15, because I don't think J should be 15. That'd give me 30% yield. That would be outrageous. So let's see what happens if I graph this. Here comes my yield curve somewhere. I know I should have a yield curve. What did I do? Oh, I know what I did. I made a sign error. One minus 1 plus X to the negative 6, right? I put one too many sets of parentheses here. Yep, that set of parentheses shouldn't be there. See how it's not there? Put one too many parentheses in. So let's get rid of that and that. Graph. Oh, good. There's my yield curve. Where do those cross? Second, calculate intersection. They cross at a J value of 0.08. Well, let's call it 0.088. So what's my actual yield? It's that doubled, right? So that's 17.6. Holy crap, wait a second. I said I wanted to earn a yield of 12%. And if I make it all the way through with no default, I earn 17.6%. The promised yield was 12%. That was what I was aiming for when I calculated that price in the first place. I'm sorry. No, this promised yield is this number. If we actually make it all the way through, the expected yield was 12%. So the difference, 5.6%, that's the risk premium. That's the extra money I earn by taking this risk on successfully. And that's the yield spread. So a risk-free bond at 12% versus a risky bond at 12% with a 5% risk attachment generated a yield spread of 5.5%. That's how I account for that default risk, Maria. If I don't trust them, I have to build that into the price, pay a different amount for the bond to cover the chance I'll get screwed. Questions? Yes, ma'am.
Guarantee that you're gonna make a profit, no matter what you default or not.
Well, let's go back and look at that. I paid $91,000, right? If they default in the first year, I've made 2 coupons, 14 grand. Ugh. Well, if they default in the first payment, I will have made 50,000 back. So I'll lose $41,000. If they default in the second, I will have made 5,700, right? I can't guarantee myself a return that's positive until I get to the last year. I still stand a very good chance of losing money. Is it, well, I said that. Now my brain goes, is it really a very good chance of losing money? It's 0.5% each time, right? So if I went back to that calculation and I said, what's the chance they will default flat without anything about worrying about the money? I could replace the no default side by a 0 and the default side by a 1, right? So if I wanted to know what's the chance they actually default, I would just have to add up these numbers. So 0.05 plus 0.05 times 0.95 plus 0.05 times 0.95 squared plus 0.05 times 0.95 to the third plus 0.05 times 0.95 to the fourth plus 0.05 times 0.95 to the fifth. There's a 1 in 4 chance I lose money. So even though it said it was a 5% default risk per period, and that's why I'm earning extra money if we make it. Now, would I be okay losing money is another question. Maybe I'm taking this risk calculated, saying, well, if I lose money, that's a capital loss that offsets some of my other capital gains and deals with my taxes in a better fashion, and I'm happier about that. So let me make this risky investment. And that's a calculation beyond what I think I need to cover, but that's a real question that we ask as fiduciary consultants, whose responsibility is to ensure that our clients don't lose money all the time. Or if they lose money in a way that works for them. I lost money I bought a house and it was underwater when I sold it. I was very happy to get the hell out of there. So to me, it was worth losing money. I think at the time I sold the house, I sold it for about 26,000, but the mortgage outstanding was a little over 41. So I lost $15,000. But I got out of a house that was going to kill me. So I'm okay with this. This happened a lot recently. As recent as 2008. That was part of the problem of the housing crash and this sort of fixed income behavior called a mortgage-backed security. 4.33 mortgage-backed securities. So a mortgage can be insured against default. The Federal Housing Administration sells this insurance policy. And if you are a first-time home buyer or a home buyer with a potentially high risk, like a moderate salary or a contingent salary, or you and your spouse are working together on this, they'll often require you to buy this sort of insurance for a minimum of 5 years, especially on a 30-year mortgage. I wrote down an acronym and forgot what it stands for. The Government National Mortgage Association sells bonds to back up this insurance policy. Government National Mortgage Association. So what does it mean to sell a bond based on these mortgages? So this is a collateral idea. I hold a piece of paper worth the value of a house. Let's pick a number out of thin air. A house is worth $250,000. I have a piece of paper that says over the next 30 years, this person is going to make this set of level payments. And at the end, we will have paid off $250,000 plus all the interest, right? We can work out a level payment annuity like that, right? So I know how much is going to come in every month. So I could say to you, do you want to buy this annuity, this coupon behavior where it pays you every month? But you don't have to buy all of it. Maybe you only buy $10,000 worth. Maybe you buy $50,000. If you buy $50,000 worth, you will get 20% of every payment that comes in, right? Because you $250,000 house, you bought $50,000 worth. What if I, instead of taking one house, take all the houses a bank owns, pool them together, and say this earns this much a month and has a net value of $100 million. You can buy part of that bond. It's got a face value of $100 million. You can buy some of it. And you get a part of a mortgage. You get part of the payments made by the mortgage holders. These are called derived securities. In this case, because they're backed by real estate, they're called real estate derivatives. Some people can add money to every monthly mortgage payment, pay the mortgage down early. It is possible for a mortgage-backed security to mature early in that case, in which case it would get called early. Now, in 2008, a lot of people stopped paying their mortgages. Their houses were worth this much. They'd refinanced, they'd taken out larger and larger loans and found themselves unable to pay it back. They defaulted. That means that the holders of these bonds found themselves holding bonds that were no longer paying. They loaned money away and people defaulted. So what happened is known as the subprime loan crisis. Now remember, we talked about a subprime loan. What was that? We had a prime lending rate, and that was given to whom? Really good customers that we trusted. Subprime, which unfortunately means rates that are higher, were to less trustworthy customers. So what happened rather thoroughly is interest rates blew out the bottom. Rates were 1%, 2%. When I bought my first house, the house I sold at a loss, I bought that at 8.5%, 8.25%. Mortgage rates right now are 6 and change, 6.4 is the national average right now. I think that's the number I remember hearing most recently on the radio. But 6 something. But mortgage rates were in single percentage points. You could get a mortgage at 1%. If I have a house that I had mortgaged at 7 or 8%, I remortgage it at 1%, cut my payments down a lot. I pay a lot less in interest. But then houses were getting more and more expensive. Prices were going up, money was cheap to get. Riskier people got mortgages. People like me. Or people who had no fixed income. People in the gig economy who didn't have a fixed paycheck could still buy a house. But when the economy started to crash, they were unable to pay it. And all of a sudden, all of these mortgage-backed securities no longer became valuable assets. But here's the problem. I have a bank, and the bank holds $100 million worth of mortgages. And I sell a bond. Adam, I sell you a bond for $10 million of this part of the mortgages, right? And you buy that bond from me. So your bank buys $10 million worth of my mortgages. So suddenly I have cash on hand and I can use that, but you have a pile of paper that's going to be worth 10 million bucks. But you don't just buy from me. You buy from Maria also. You buy from Joe also. So you have $30 million worth of mortgages. But they come from different places, right? You then decide to take that, roll it up into one big bundle, and start selling slices of it. You're not direct mortgage, you're second derivative, not first derivative. I actually held the mortgages, and then I sold you part of it. You then sell part of the parts to other people. Maria buys some of them. And she buys from you and from me and from Joe and from several other people and bundles up her pile of mortgages and slices that up and starts selling that. So one of the things that happened with this mortgage-backed security is that we got derivatives of derivatives of derivatives. And in the long run, we ended up with what was referred to as an untraceable asset run. I couldn't figure out where things came from. So what happens when all these people start defaulting? The paper you sold to Maria is no longer worth anything. Maria can't collect that money.
So she comes back, you goes, what? And you go, well, I got that from Josh. Let me go to Josh and he'll tell me. And I go, well, I bought that from so-and-so's bank. Whose mortgage are we actually getting money from? Nobody knew. To the point where National Public Radio and the company, the story company, This American Life, did exactly that. They bought somebody's pile of paper and went to find the people. Whose mortgage is this? Well, this story right here, this link, will walk you through that. And I wish, no, go away. I really want to tell you, they actually made a Toxie the Toxic Asset plush doll. I thought it was hysterical. But they really went out and walked through the entire thing, and the entire transcript is available here. I think this is an important thing for you to read. And it will tell you more about the way in which we look at and purchase and arrange bonds. Questions? So make sure you hit that link for Toxie the Toxic Asset on our Canvas page. We can hedge against other types of risk. So in here, we were hedging against default. But I can also say I bought a bond with a coupon rate of 4%, but suddenly inflation hits 12%. My coupons are actually losing me money. So how can I protect against inflation? Well, there are different kinds of hedged securities. The ones that are against inflation are guaranteed by the Treasury. Treasury inflation protected securities. They're called TIPS. And if you go to the Treasury website, treasurydirect.org, you can examine how to buy those as well. The rate of inflation adjusts the coupon payments, which means we have an inflation adjusted annuity, which is why we covered that back in chapter 2. Yeah, I know what to do with those. The typical phrase for a bunch of paper owned by some bank, cut up to make bonds, that's called a collateralized debt obligation. And a piece of that is called a tranche, Tranch. I wish I knew where this word came from. I haven't been able to find a good definition. I believe it's French. But if you look at the bond market today, you'll see tranches of so-and-so's company listed at different points. I could go a lot further into this. There are a lot more examples in section 4 in the text. Take a look. If one of them speaks to you, let's talk about that one. But that's as far as I get in chapter 4, which means we finished chapter 4, which means we've got a homework assignment due in a week. So if you've got questions, come bug me. Otherwise, I will see you on Tuesday. Yeah, just a sec.